Welcome back to the channel, Bridging the Gap, Student to Engineer, where STEM professionals provide advice to students. If you're new here, please like and subscribe. We would love to have you join our community. If you have any questions as we go along, please leave a comment in the video, and we always provide resources and links in the description for the video, so check those out as you watch this video or afterwards. So this video specifically is a discipline deep dive into robotics engineering. I have also included mechatronics engineering. When professionals are talking to K through 12 students about STEM, the go-to subject is typically robotics. There's lots of robotic competitions. You might be watching this video because your student has excelled in a robotics team at school and is now interested in robotics engineering. That's how we're getting a lot of kids these days into STEM and more specifically into engineering careers. What we don't talk about as much is mechatronics, and mechatronics is a wider discipline. If you look at the word mechatronics, it's a combination of mechanical and electronics. And so if you break it down to its core, it's really mechanical systems being operated by electronics. And if you think about the application of that, while robotics fully is within that scope, mechatronics can be a number of different things. I will provide a link to a video that talks about the difference in the comments or the description for this video, so you can go look at that if you're interested in the difference. But for the purposes of this video, we're going to be talking about them as one thing and as one possible career path generally that a student can take. So robotics engineers, mechatronic engineers, like all engineers, identify, formulate, and solve complex engineering problems by applying principles of engineering, science, and math to some specific things. So in this case, these engineers design, develop, diagnose, analyze, implement, operate, optimize, and or manage mechatronic systems. So an engineer with a robotics or mechatronic title is going to be either developing or using a system that's already in place, or managing or optimizing those systems. And the systems specifically that they're going to be working on is a system that is a mechanical thing controlled by an electronic control system. They are really good for specific applications because they integrate mechanical, electrical, and programming to design, create, and test product with smart features. So there's a couple new things with this dot point. Mechanical, electrical, and coding. That is where the robotics and mechatronic engineers really have their skill set. I know there's a lot of discussion about, should I be a mechanical engineer? Should I be a robotics engineer? While you can apply mechanical engineering knowledge to the world of robotics and the world of mechatronics, if you get a degree that's specific to robotics or mechatronics, you're going to have a more cross-discipline education that's going to bring in all of the major elements that you would need. And those include mechanical, electrical, and coding or programming. You can major in these other disciplines. You can go get a more general degree. And if you've got a university near you, or a university that you like more that just has mechanical, I would say that you can go get that degree for sure. And you can just make sure that when you are looking at your electives that you try to get some electronics in there. You will have some electrical in your education, but if you can branch out a little bit and try to add some of those classes, and then also get a good base in coding. All right, so robotics and mechatronic engineers are going to lead cross-discipline teams working on automated or intelligent systems. In the previous bullet, we said smart features. If you just think about the world around us and how technology is integrating more in our lives, there's lots and lots of different systems where we have a mechanical system being controlled by some sort of control system, electronic controlled system. And so there's just a really wide application of this. The robotics and mechatronic engineers are going to be the ones that are going to be leading those cross-disciplinary teams to put those systems together. That's not to say that you're going to lead a team when you graduate, but as you move up, leading teams that are cross-disciplinary, and you're going to have the education, the background for mechanical, electrical, coding, all of those things, understanding the whole system and being able to lead the team. I suspect that if you are a robotics engineer in school and you're looking for internships and full-time jobs, what you're going to find is that the managers of those teams are probably either mechanical, electrical, computer science, or something else. They probably are not going to be a robotics engineer because the discipline of robotics engineering is somewhat new, or at least newer than these other disciplines. So this is going to be one of those majors where you're going to have to explain yourself to recruiters and companies unless they've already hired a few themselves. But we'll get into that when we get to employment data. Right, so the career outlook is there is no data because the Bureau of Labor Statistics does not recognize this as a discipline. I just like to leave this slide in here because if I had it, I would show it to you. But we will get into the employment information for a couple schools where information was available, and we'll talk about that. All right, so industry organizations, if you've been watching this channel for a while or you've seen the other videos, you know that I think it's really important for students to get involved in industry organizations. There are huge organizations like IEEE that cover thousands and thousands and thousands of professionals. And then there are much smaller organizations where they might just be more excited to have students involved. But the larger ones will typically have competitions, sometimes student competitions that you can participate in and get recognition that way. But industry organizations are really good for finding scholarships, making connections, going to conferences. If you can become a member, a membership in these type of organizations actually a really nice gift for an engineering student because it connects them to the industry in ways that they never would have known otherwise. All right, so if we talk about schools, we talked about like mechanical, electrical. Those have hundreds of ABET accredited programs with that title. And when we get into robotics and mechatronics, the list is much smaller. We're talking about 19 schools. And you might ask why, because there is certainly more of a demand for engineers going into the application of robotics and mechatronics. And the answer to this is that most of the time, the students who are interested in that are majoring in other things. They're majoring in the base core engineering subjects, and then they're going into the specialty. There are some schools that pride themselves in being a core location for robotics, and some of them host lots of robotics competitions. And if you want to get into robotics competitions or you want to continue what you're doing in high school, I would suggest looking at those schools. I know Kettering is one of them, but you will not see Kettering or a lot of other larger schools on this list. My observation as I was looking through it is this is a lot of smaller schools that are either specializing for the local job market or wanting to get a specialty so that they can attract students that would not normally come to their school. I will point out Worcester Polytechnic Institute, WPI, at the end on the lower right here. They are a little bit more of a bigger and more well-known school, specifically for tech. But for a lot of these other schools are local state schools. So there's nothing wrong with that. But just something to look at if you're wanting to go to a really big school with a big football team and have that type of college experience. You may want to look at the more core engineering majors like mechanical and just see if they have a robotics specialty or a robotics lab at that school. So let's just get into what the outcomes are. So generally, when we look at student outcomes, the larger schools are easier to get the data. So there really are not very many schools that have robotics and mechatronics who share their data. So I will go over what we have and probably a little bit differently than I usually do. So the first one is UC Santa Cruz. The program is not ABET accredited, but they have a program, and it looks like they're working towards accreditation. It is a pretty small program as far as the total engineering. They've got about 3% of their total engineering grads are in this, and their positive outcome rate 65%. That is by far the lowest on here, but it's actually a little bit higher than what we've seen in other majors at UC Santa Cruz. So don't usually recommend, and I'm not recommending at this point, going to a non-ABET accredited program. But I wanted to just throw this out there that there is an option at some schools that are not ABET accredited, and there still are grads going to them and getting jobs in the area. WPI, Worcester Polytechnic Institute. This is on the East Coast. They have a much larger group that is majoring in robotics, and they have really good positive outcome rates. They're at 94%, although they do have quite a high percent of students going to grad school right after their undergrad, so that's something to consider. But their median starting salary is on the higher end of what we see at usually at schools. And then Anderson University and Vaughn College of Aerospace and Technology, they both have programs. They are a little smaller. They do say that they place all their grads. They really don't have a ton of information available. But overall, I would say that if you are interested in majoring in robotics, I would ask a lot of questions at the schools and understand that you're probably going to be going to a smaller school to get that specialty. Now, whether or not I would recommend that over majoring in mechanical electrical at a school that has robotics is kind of questionable. I know these are good outcomes, but it really just depends on what kind of college experience you want. If you want to be at a school that is more recognizable, then I would say find one of those schools that has a robotics concentration, but not necessarily major. On the other hand, going to some of these smaller state schools and other schools that we've seen with a specific robotics major, at this point, you're going to have really good job prospects when you graduate. And I mentioned earlier, just looking at the world around us and how much we see mechatronics and robotics just being a part of our everyday lives. That is exploding, and so your ability to get something in the industry is going to be pretty good. Just one last comment on that. I generally don't recommend students major in aerospace because that is a major that is specific to an industry. Similarly, robotics is a major specific to an industry. The issue with aerospace right now is there are too many grads for the number of jobs in that industry. In robotics, there's a lot fewer schools and still a pretty wide open job market. So we may not have gotten to the point yet where that is an issue. Right, so employers, there are lots of employers from the data that we could get, but what we're seeing is patterns of companies in the automobile manufacturing, defense and space, and then on the lower left side, quite a number of companies that do robotic consulting. So, understanding how they can go into a company that has manufacturing and help them optimize their system and use their robotics or the mechatronics systems to improve their work. And so that's exciting work if you like more varied work, not necessarily with one company or one industry, but working across a lot of different areas. On the right side, we've got Bechtel, Sargent and Lundy, and Parsons. Those are all design and or engineering construction companies. And so they're going to have control systems engineers that are going to be designing the control systems within large plants that they're designing and building. And the rest, almost the rest of these are a lot of manufacturing. So Caterpillar, Cummins, John Deere, those are manufacturing large pieces of equipment for various industries. Amazon, you can imagine how they are using electronics and robotics to pick the things that we buy every day. I wanted to point out the one on the bottom, Universal Orlando. This was a grad that was hired as a control systems. So we think about entertainment and theme parks. All of those rides are heavily dependent on mechatronics systems. So being able to go into that industry, if that's something that you're interested in, is definitely something that you can do. So first, job titles. A lot of these I think are pretty self-explanatory and what we would expect. Robotics engineer, control systems, mechanical engineer. So you can major in a specialty and have a job title that is the more general engineering. But systems integration test engineer. So you're integrating different systems, automating things. Because one of the three core areas for robotics and mechatronics is programming or software. Someone graduating with the title of software lead just fits right in with that. But the last two, I think, point to what a lot of engineers get into, particularly as they move up in their career, and that's project management and leadership. So for these engineers to graduate and become an assistant project manager or getting into a leadership development program are great things to do when you first start out. In most careers, there's either technical path or leadership path. So these two titles would be places where new grads would go where they're already starting along that leadership path rather than technical path. Okay, so resources, I will provide the links in the comments for this video. There is a YouTube channel. There's a lot of videos out there, but this one seemed like a good one to compare robotics versus mechatronics. So if you are looking at schools in the different areas and wondering, that's a good video. And then the International Federation of Robotics, that was one of the industry organizations we talked about. They've got a topics and definitions section on their main page, and I'll provide a link to that. That's a good place to read for different things. And then NASA's Robotics Alliance project, they have a lot of information about robotics, including a large section of their website with all the robotics competitions that you might look into if you are interested in those. Right, so that's what we have for robotics and mechatronics engineering. If you have any comments or questions or want to contribute to the conversation, please leave a comment in this video. And as always, please like, subscribe, and share with a friend. We'll see you on the next one.